All right. Well, good morning, everybody. Maybe it's not morning when you're watching this, but that's certainly when I'm doing this. So here we go. Welcome to day one of your online learning. Kind of a couple goals with me and the way that I'm doing this. One, I want to try and have some sort of sense of normalcy in kind of a weird time. What I mean by that is I'm just doing this live. You get one take. It's whatever happens is going on YouTube and it's staying there, just like it would happen in class, right? Like I can't run it back and recreate a class or say, everybody pause, let's rewind that bit. You get what you get. You are welcome, certainly, to tune in live, but by no means do you have to. You can watch this at your own time and leisure. You're going to get plenty of dumb jokes and gifs throughout the way. That's not really going to change. So with that, let's get into it. As is tradition, we typically start with, hey, this is some stuff that you probably learned or should have learned in Math 3. We're going to do some work with laws of exponents. We are switching around EO7 and EO8. The orders of those two have switched, partly just because we felt it was going to be easier to get on board with all of this online stuff by doing the EO8, which is exponents and logarithms. Okay, so plenty of log jokes coming up here in the future. But let's start off with just exponents. Your first law property basically suggests that when you multiply things with the same base, so like these guys right here, that's going to give you an addition of their exponents. Okay? These bases have to match. If these two things aren't the same, and this can be a number, it can be a letter, add those exponents. Let's see how we might actually use it. If I gave you x cubed times x to the fourth, what's that going to come out to be? Well, we can see that we're matching this form here where we have the same base that's being multiplied. So what's my result actually going to end up being? In this case, the base always stays the same. You'll notice that a here, that base value, ends up still being the base. And I could rewrite it as now the exponent, 3 plus 4. I'm doing this with my mouse rather than my finger on the screen. That might change over time. What's that whole thing going to turn out to be? Hopefully you can handle that addition. X to the 7th. I could chain multiple x's on here. I mean, I could have 3 or 4 terms all with x as we're going through. But it works with as few as 2. If we were to now try something like this, you'll notice that I have basically 2 different bases here. I have the a's here with the blue, b's with the green. If we don't see an exponent right here, we got to think kind of what's actually going to appear there. And we know that the number that we don't write in the case of exponents is a 1. So if I kind of want to rework how this looks, if I were to basically rewrite the location of these guys, I'm going to have my a cubed, apologies for that, 3, and I'm going to put times a squared right next to it. The idea is I want to match my bases together. So I'm going to put my b's next to each other. It doesn't have to go alphabetical. It's more important that these same bases are next to each other so you can kind of see, oh, right here, I basically have that same law property, that first law, but it's happening in 2 different cases. So I'm going to handle each of them the same way, but we're going to see it appear in different places. A cubed times a squared, the base is going to stay the same. What's the exponent going to be? I've got a 3 here and a 2 here. When I multiply the same base, add your exponents. 3 and 2 is going to make 5. My next terms are all b bases. I've got a 4 and a 1 for those exponents as well. Same deal. The bases are being multiplied and it's the same, so add those exponents, you get a 5. I actually don't know if my handwriting is better or worse than normal with this. You guys have certainly seen how low it can go. All right, moving on. Everybody's favorite, fractions. They're going to appear. We're going to continue to throw them at you. Everything that we've said is still true. I'm multiplying things with the same base. I have a w and a w. I need to add the exponents. At the most basic level, you could write w and then raise it, and this is going to look a little nasty, to the 1/3 plus 2/5. Now, don't just leave it like that. We're going to actually want you to simplify this. I need you to add those fractions. Think for a moment, what do you need before adding fractions? I ask this a lot. It's not my favorite word, but it's up there. And I'm absolutely going to be having coffee too. We know that as well. I need common denominators. I've got a 5 and a 3, so I'm going to turn each of these off to the side into 15ths. That's my common denominator for both of those. I'm showcasing this. If you can just do this piece in your head, great. Go for it. I'm going to multiply this guy by 5 fifths, which is going to give me a 5 15ths. That might be better than I normally write. Ooh, all right. Spoke a little too soon. I'm going to multiply this guy by 3/3. Yeah, okay, I did speak too soon. Oh, the hubris begets my fall. It's going to give me a 6 15ths. This is, again, if you can do this work in your head, or you can kind of go from this step just to having the common denominators now that they're both at 15. I apologize for that. You can go right to adding. I'm going to write an intermediate step. You don't need to. Our 1/3 turned into a 5 15ths. Make that slightly better 5. Well, I say that. And then I'm adding to it. And again, these are all in the exponent. It's a little weird because they're fractions, so their size difference looks a little odd here. I'm going to add 6 15ths. Now that they have that common denominator, just add the numerator straight across. That's going to give me w raised to the 11 15ths. Same process, still works when I'm multiplying pieces with the same base. Add those exponents. You've got to do a bit of other work, but all of the properties of math that you've known and grown to love before still happen to exist. You can effectively count how many you have. That idea gets a little bit weirder with fractions, but like if I look at something like this, what do I think an x cubed really is? It's an x times an x times an x, 3 of them all written out, times an x to the 4th, 1, 2, 3, 4 x's all in a row. So what do I really have? 1, 2, 3, 4, 5, 6, 7. That's why that ends up becoming sort of the exponent here. You could expand it all the way out if you wanted, and sometimes that helps at a beginner level. But we've seen some of this sort of stuff before. We're generally going to basically just add those exponents. Other rules that you know might apply or add on top of that, and that's all fine. Law 2. Basically the same idea, except if multiplying the same base meant adding the exponents, dividing the same base means subtracting the exponents. You can kind of also look at this as sort of a canceling out here, which is something I know people love to do. We'll talk about law 7 naturally later if we're on 2. We'll get there in a moment. I'm going to show you what I mean by sort of canceling, though, for the first method through here. If I have x cubed over x to the 4th, what I mean by like where are there leftovers, I'm going to actually literally expand these. So I'm going to write x times x times x all over. Now I've got to do 4 of them. That's more of a y. Okay. And I see Josh is here in chat. Good morning, Josh. Tuning into a little bit of bonus math for stuff, but cool. I'm going to basically now start to cross cancel these pieces out. I'll use sort of the red here. I have in this case an x over an x. It's literally division. Both of these guys are going to divide out to a 1. If I start crossing through all these pairs, where's my leftover? I have one guy down here in the denominator. What's that leave me with? Well, I have obviously the x in the denominator. Think I've cross-canceled all of these guys in the numerator. What remains? Many people want to say 0 or that it's just gone and leave your answer as just x. That doesn't work. When we're cross-canceling, we're really dividing it down to 1, so my numerator is still a 1. This is 1 over x. There it is with a positive exponent. If I needed to, I could write a 1 over x to the 1st. We're usually not going to write that exponent, but understand that it's there. Let's flip it now. Where are the leftovers going to be? For this one, I'm going to kind of type it out, just for time's sake. Change that font size. So m to the 8th is going to be m times m times m. Oops. Boy, if I could type, that would really help, wouldn't it? And we're just going to cheese this guy a little bit. We've got, at this point, 8 m's. Oops. Again, there's going to be a few hiccups here and there. All over, 3 m's is going to basically look like this. I suppose I could make those font sizes a little larger and it's not going to hurt anybody. If I start cross-canceling these m's out now, let's see what's going to happen. Lost my mouse. Where the leftover is going to be, I'll go with the blue. I'm certainly going to lose all 3 on the bottom, and if you kind of compare it, there's like a just raw size. Wherever the smaller one is, those are all going to go away. What am I left over with right here? As you can see, I've got 1, 2, 3, 4, 5 m's. You could write m to the 5th. And then what's in your denominator? When we cross-cancel those completely, there's a 1. Simplify your final answer, m to the 5th. There you go. Again, same process. Sometimes cross-canceling is easier. Sometimes subtracting is easier. If we went back to the way the law is stated, we see I'm dividing the same base. I've got an 8 for my n variable and a 3 for my m. If I were to subtract those, 8 and 3, that gets you your 5. You can choose which one makes the most sense for you. There's kind of different options for both cases that work better than the other. All right, let's throw a couple variables at you. Going full alphabet here. Where the leftover is going to be. I'm not going to expand this whole one. I'm just going to kind of like reason some of this sort of thing out and tell you, because we want to get you to a point of fluidity where this is going to go a bit quicker. With my a's, again, I can ignore the b's and c's because I have a to the 5th divided by a to the 9th. I'm doing this law too. I'm dividing these terms with the exact same base. I've got a 5 and a 9. So if I were to cancel all of these out, all 5 a's in the numerator are gone. I've got, at this point, it's going to take away 5 a's from the denominator. I know I'm going to have an a to the 4th left over. The subtraction piece would give you a -4, and we're going to come back to that when we get to law 7 with how negative exponents work. For now, that's kind of a little bit of a teaser for where these things are going. If I repeat the same process with b's, I have 4 on top, I have 2 on bottom. If I cancel out the 2 on bottom and 2 on top, I have 2 left over on top, so I'm just going to write a b squared up here. And then I have a c squared over a c squared. 2 c's on top divided by 2 c's on bottom. Those are going to cross-cancel completely out to a 1. I could write times 1 and times 1, but we don't need to, right? Just ignore all of that stuff. What's my final answer going to be? Oh, I don't ever really go to the eraser. Oh, goodness. I'm so used to the physical eraser in class. There it is. There's not really anything else you can do to simplify that. You could expand out, and if you really wanted to write 5 a's, 4 b's, 2 c's for the numerator, expand out the denominator and cross-cancel, you get the exact same thing. So, law 2, when I say it's canceling common variables from the top and bottom, take a moment to kind of look at these phrases here. You know how to read, and it's the same sort of thing that I've been saying as we're going. One thing that is going to be a little bit different too, that I'm a little more excited about, at least by the constraints that we have, is that I can have a slightly different class. They are both zonked out right now. This big white one right here is Kona. There's a little guy on the other side that you probably can't even see. That is Obi. He's basically whatever Kona does, Obi's going to do. We'll give him a treat. Why not? Oh, there you go. Obi, you want a treat too? For camera? There you go. All right, moving on. As I said, there's not going to be any lack of dumb jokes. You might choose a different word there, but here we are, okay? Law number 3. This one often gets a little confused with law 1. Be aware. What's really happening here, and I could write this sort of another way, I have an exponent raised to another exponent. So this is effectively a to the n, and then after I've done that, I come along and I raise it all again to the nth power. What happens really, ooh, I apologize, this guy's in the wrong spot. you multiply these two exponents. I take whatever value n and m are, multiply them. We'll talk a little more in the next slide about how that might sort of look if I were to expand this all and why that's actually going to work. Let's move this guy. If I were to just straight up use the law, it's going to end up being a x to the 3 times 4. I don't know why all these dots are in the wrong spot. I apologize for that. You can multiply those. It's going to give me x to the 12th. If you want a quick rationale on why, I'm going to kind of type this out. What I'm going to basically have is x times x times x, and I'm going to have that thing now multiplied by itself 4 times. That's what that top 4 exponent's going to mean. Let me clean this spacing up here a little bit. This is the full expansion of this guy, and I'll make it a little larger for you. At this point, you can probably now visually see, do we have those 12 x's? Yes. I don't ever want you to write this all the way out. Recognize I have an exponent raised to another exponent, multiply them, move on. You can see why I don't want you to write these sort of things out. If I gave you a to the 30th and then asked you to square that, that's going to be 30 a's, and then right after that, 30 more a's. They're all multiplied straight in a line, so you're going to have 30 and 30. How much is that going to make when you add them because they're all multiplied? That'd be 60. That's why we're allowed to use this property. Final answer for this guy, multiply those two, going to be a to the 60th. Our good friend is back, fractions. Seems like we might have lost Josh, unfortunately, but that's all right. Credit to him at least for tuning in a little bit. It's the same property. I have a base with an exponent raised to another exponent. We're going to take and multiply these. Sometimes you might see me start to like arc these in to remind you of like distribution properties that you've done. Be a little careful with that thinking, but you will see that. It's different than distribution. We're still doing the same property here. This is now going to be t raised to the, I'm going to write this out, 2/3 times, I need to multiply by 5. I'm going to make this 5 over 1. How do we multiply fractions? We're going straight across. It's going to give me t raised to the 10/3. There's not really much I can do with this. We'll do some work with radicals here in a bit, but for now, that's it. It's all you could really write and clean up with. We are going to bring a bit more properties with some of these in a moment, but just multiply your fractions, nothing too crazy. People get law 1 and law 3 mixed up because the idea is, are you multiplying the same base? Add the exponents. Do you have multiplication of exponents? People then start to flip around. Okay, wait, am I supposed to add these now? Be careful about the order of these. They do make a difference. This first one here, as we've talked about, multiply the same base, add the exponents. Here, I have an exponent raised to an exponent, so I multiply them. Both have multiplication in there somewhere. Be careful you don't make the mistake and switch those around. And if you do, okay, we'll fix it. Laws 4 and 5 are effectively the same thing as kind of like 1 and 2, where we had multiplication and division kind of coming out in two different ways. Really, this just showcases how if I have an exponent outside of parentheses, you'll notice there's no addition or subtraction in here. That's a totally different thing. This is when we are going to get basically distribute these guys down to each part. What we mean by fairness laws is like, hey, we're going full Oprah. This A gets an M power. This B gets an M power. But this only works if there is no addition or subtraction. That's something I've been harping on all year. It's going to continue. Law 4 and 5 only work as long as there's multiplication or division of all the terms inside the parentheses. Let's try it. This is going to combine a little bit of two pieces here. This is where you'll see me start to do this distribution. I have no addition or subtraction, so I'm using basically a law 4. This 5 is going to multiply into each of these. Now, the first part that we said, this is going to go right back to law 3. I've got x squared raised to the 5th power. What's that part going to turn out to be? Well, law 3 was when I have a power raised to a power, multiply those. I'm going to get x to the 10th. We don't see an exponent on m right now, so we know that it really is a 1. We have a power raised to a power. You're going to multiply those. 1 times a 5 is going to give me m to the 5th. Both of them get a 5th power, but since the x already had a 2, we're still going to use those same properties and apply it. He's going to end up having basically 10 x's overall versus 5 m's. Let's try another. Don't freak out. Again, we're applying this to every single part. I'm going to multiply this guy into the p to the 5th. People like to drop it if it doesn't have a written exponent. I'm always going to make this little arc here. We know that it's a 1, and I've got 3 here going to that 4. We're basically right now just back to law 3. Now that we've already accounted for all of these, I've got p to the 5 to the 3rd, which is p to the 15th. Just like with the last one, when I have something that has a 1 exponent, it's basically going to copy over because you're going to have a 1 times 3. It's going to give me t cubed. And then I've got k to the 4 to the 3rd, which is, multiply those, k to the 12th. Some people are real particular about alphabetical order. I'm not concerned in the least. Good morning, Osa. All right, we got people popping onto the live stream. Math 2 year long is going to be a little bit later. But I like that people are actually able to pop in and make use of this. Very cool. I'll try and get a better idea about posting when I'm intending on doing the live streams if you want. If you're just watching this at 10 p.m. because you couldn't be bothered, I have no problem with that. That's the advantage, at least in this case, of the asynchronous learning is you do it when you like to. Move some of this guy out of the way. Again, plenty of dumb jokes, dumb memes, silly pictures. Nothing's going to change in that regard. Don't freak out. This is law 4 and 5 together. I'm going to take this 3 and distribute it to every single thing. Oh, I'm sorry. There's actually a couple other pieces there I forgot. We've got, before I do my next step, I've got a few other things right here. I notice right now I've got a p to the 4th and a p to the 1st. Those guys are being multiplied. That's going to take us all the way back to law 1. I've got a bunch of stuff in here that I can clean up. So we'll actually do this one probably 2 ways. Let me make certain I have a second slide for it. Yeah, let me go ahead and copy this guy. So we're going to first clean up using laws 1 and 2, and then we'll come back to that distribution property. I'll show you what I mean, because we can do this thing 2 different ways. So I'm going to make still this big old honking parenthesis, big fraction bar here. I've got a w squared and a w to the 5th and a w to the 4th. So right here, if I look at just this w to the 5th and w to the 4th in the denominator, that's going to be a w to the 9th. We're going to do this in a couple steps. So I'm going to go ahead and write my w squared here, because there's no other w's up top. I was multiplying right here with the w to the 5th and w to the 4th. Bases, or sorry, same base, so I'm going to add those exponents. That's where I'm getting w to the 9th. You might start to realize we've got some division here, so we're going to do law 2 in the next step. I have a p to the 4th and a p right here to the 1st in my numerator, so I get to add those exponents. I've got a 4 for one of them, a 1 for the other, add those together to make 5. D, just sitting on its own, I'm going to write in d to the 1st because this is sort of the work that I'm doing just to help me keep track of those pieces. Then I'm going to put my m to the 7th because there's no other d's or m's up top. If I go down to the denominator, I've already dealt with the w's. I've got just one p right here, p to the 1st. D to the 4th, there's no other d, so I'll just copy that guy. Ooh, boy, there's a font is a variable here a little bit. I've just got m to the 7th, right? There's nothing, there's no other m's down there. At this point, oh, and this is all still raised to the 3rd power. This is the sort of level we're going to kind of want you to get to, at least with fluency with some of these. We will see this sort of style problem on the test where it's going to throw a whole bunch of pieces at you and ask you, hey, what's the answer going to come out to? I'm now going to kind of move down here. Oh boy, we could do a better job with that one. Good morning, Kayla. See Kayla Dayhuff is in here. So, all right, I'm glad that this is kind of working. A little bit. All right, I'm going to start cross-canceling within the inside. I'm not worrying about this 3 exponent up here. We'll deal with that one last. On the next time we do it, I'm going to kind of change the order around a little bit and show that we're still going to kind of come out with the same answer here. At this point, let me switch to maybe the highlighter here. That might make this a little easier. These guys are all the same. If you look right here and match these colors, I'm basically matching exact same base, and I've got division in between them. That's what that fraction bar is going to mean. Let's just straight up divide them. That's law number 2. What's that going to look like? We're going to subtract those exponents. So I still got this big old fraction here. Still got a 3 up top. W squared over w to the 9th. Sorry, we've also been talking a little more canceling. I've got 2 up top. I have 9 on bottom. All 2 up top are gone. If I take 2 away from the bottom one, because 2 of those are going to completely cancel, I'm going to have my w's still in the denominator. There's going to be 7 of them left. P's, I've got 5 up top. I got 1 on bottom. If I cross cancel, I have enough fingers to demonstrate this guy. We're going to be down to 4. So I'm going to put my p to the 4th. And you'll notice that I'm stacking it over here just because I'm kind of justifying everything to the left side. I don't know if that's mirrored. Yeah, no. I'm looking at the camera here for a moment. That's going to be a weird backwards thing for me to kind of try and adjust out. I'll get better at all this too. D to the 1st over D to the 4th. I have 1D on top. I have 4 on bottom. These guys cross cancel, leaving me with 3 on bottom. I'm going to put D cubed down here. M to the 7th over M to the 7th. That would be 7 on top, 7 on bottom. They're going to cross cancel completely, leaving me with just a bunch of 1s. Okay? I don't need to really write anything because I already have something in both my numerator and denominator. Don't mess with it. Moving on still. At this point, this guy's as simple as it gets, and I have this 3 exponent outside. Now we're going back to law 4 and 5, those fairness laws. This 3 is going to distribute into every single piece. He's going to multiply to each one of these. I should have had an Oprah gift lined up. I apologize. I'll do better. This is p to the 4th raised to the 3rd power back to law 3. All of them work together. Multiply those guys. That's going to give me p to the 12th over. That's all that's in the numerator. The next pieces are now in my denominator. I have w to the 7th raised to the 3rd power. Multiply those guys. Gives me w to the 21st. That's interesting too. D cubed raised to the 3rd power. Again, we're multiplying. We're just doing law 3 now that we've accounted for all the distribution. That gives me d to the 9th. We're going to do that another way. That's one way where I basically chose to do laws 1 and 2 first. Clean up everything inside, then distribute the exponent. You can do it a different way. As long as you get the same answer, we've got a p to the 12th, w to the 21st, d to the 9th. Works for me. Let's move on to the next one. Or sorry, I guess a repeat of the first. What I'm now going to do, this is going to get a little wild, we're going to distribute this 3 to every single piece in here. Because maybe you recognize that and you think fairness laws right away. I'm going to do law 4 and 5. Cool, cool, cool. No problems. That's going to work just fine. Let's take this 3 and I'm going to distribute it. Don't forget these guys where it doesn't have a written exponent. It's a 1 there. To every single piece. For clarity's sake, I'm going to do the same thing for the denominator, but I'm going to kind of do a different color here. It's going to get a little wild. When you're doing this work on your own, I wouldn't necessarily recommend writing all of this in. It does start to get a little bit wonky where everything's going to track here. Okay, let's clean this up. We're still going to have a massive fraction, but this 3 is going to be gone because we're now taking it, distributing it all the way in. W squared to the 3rd, by that distribution, it's just multiplication. I'm going to do 2 times 3. That's going to give me w to the 6th. P to the 4th to the 3rd, it's law 3 again. Multiply those guys, p to the 12th. D, D initially didn't have an exponent, right? It didn't have anything written, which means it's a 1, so that's just going to turn into d to the 3rd after I bring that top exponent down. I'm going to repeat the process to get an m to the 21st. and then a p. This doesn't have an exponent written, which means it's 1, so we multiply. There's p cubed. Whole bunch of stuff. We're still only about halfway. We're going to keep working our way through. I'm going to go a little faster on the bottom, see if you can repeat the process that I did for the numerator for the bottom to make sense, make sure it makes sense. I'm going to get a w to the 15th. I'm going to get a p to the 3rd power. This is going to give me a d to the 12th. I'm going to get a m to the 21st. And I'm going to get a w to the 12th. How'd you do? I'm going to kind of copy this whole guy right here just so this one doesn't get super jammed up. Scroll this down a little bit. Okay. Definitely going to use a highlighter for this because you can see how it gets a little chaotic pretty quick. Where do I have any W's? Got all of those guys right there. Now I'm going to kind of do a combo of 1 and 2 together. I see right here that I've got 6 W's in my numerator. I've got basically a 15 and a 12 in my denominator. I could write another step where I combine the 15 W's and the 12 W's into 27. Law 1, multiply in the same base, add the exponents. But I'm just realizing at this point, okay, I've got 27 W's on bottom, I have 6 on top. If I start cross-canceling those, all 6 up top are gone. Take away 6 from that 27, that's going to leave me with 21 W's in my denominator. So, still make my big old comically large fraction, but I'm going to write now w to the 21st. Again, I had 6 up top, I have 15 on bottom, and another 12. There's 27 on bottom. If I cross-cancel 6 of those, that's where I get this 21. Let's repeat that process. I'm going to go a little bit quicker for these next letters. I have a, oops, sorry, let me change that color. P to the 12th, I have a P to the 3rd, and I see a P to the 3rd. I can kind of realize, well, hold on, this P to the 3rd and this P to the 3rd, those are the exact same, right? They're going to completely cross-cancel each other. These pieces are gone, leaving me with just a P to the 12th. I could also think about it as if I had 15 on top and 3 on bottom. If I take those 3 on bottom away because they're going to cross-cancel completely, you're still going to have 12 up top. There's P to the 12th. Like frame rate and everything is holding all right too. Excellent. Okay, we've got 2 more letters to basically work our way through. I've got a D, oops, I'm not changing these colors very well. D cubed, D to the 12th, 3 on top, 12 on bottom. All 3 up top are going to get canceled, and I'm going to lose 3 on the bottom, which is going to take away 3 from the 12. That's going to leave me with 9. So I've got D to the 9th down here. This time I'm going to remember to change the highlighter color. M to the 21st and M to the 21st, 21 on top, 21 on bottom. They cross cancel completely. I've got P to the 12th, W to the 21st times D to the 9th. How did that match our previous slide? Come on, let's scroll. P to the 12th over W to the 21st times D to the 9th. Same thing. It's worth trying both ways. Ultimately, you're going to kind of figure out which one makes the most sense and works best for you. I don't care. If you were to write it with these parentheses here, great. It doesn't hurt. It doesn't help in this case by the end. Either way. Law 6. Moving on. I must have a blank slide here. My apologies. Oh, okay. We're going to go quick through Law 6. It's something that's always going to be true, except for one time that it's not. 2 to the 0, what is it? You might already know. Ooh, change back to a pen. 1. Let's show you why. 2 to the 5th, we know is going to be 32 because it means 2 times 2 times 2 times 2 times 2. I got 5 of these all multiplied. 2 to the 4th is 1 less 2. 2 times 2 times 2 times 2, which gives me 16. 2 to the cubed is going to give me 8 because I have 2 times 2 times 2. Repeat that process for 4 and then 2. So if we look over here, there's basically a pattern where each time I'm losing a 2. And what I mean by losing a 2, ooh, got a little wild. I'm really dividing out a 2. So if I could go from 32 to 16 to 8 to 4 to 2, what does the next one have to be? I'm dividing by 2 each time. Oh, Luke in the chat already got it. Luke Biller, everybody, popping online. It's a 1. I don't know when he said that. I apologize. I'm not the best at juggling some of these times here. There's the y. It doesn't matter what this base is. It's going to work no matter the case. If you've got questions about 0 to the 0 and you're moving on to calculus, you'll get to deal with that. It's kind of a weird case. There's not one single answer. For your purposes right now, if I give you something to the 0, it's equal to 1 as long as that base isn't equal to 0. What's 4 to the 0? We go to chat. I don't know if Luke's still here. Come on, Luke. You can do it. A 1. Is it a 0 raised to the 0? Nope, it's a 1. What's 10 to the 0? 1. What's x to the 0? 1. As long as x itself isn't equal to 0. We might mess with some of these edge cases. Consider that if ever x becomes 0, that's a problem. You could start to basically take this 0 and apply it in here, but realize that right now, I'm just going to kind of draw a big old rectangle over this. It doesn't matter what's in here. You have something raised to the 0. What's that going to be? Yeah, Bella's got it. 1. I don't quite know the time delay on some of the YouTube stuff here, but I've got a little bit of participation. I like it. Thank you. What is 2,576,234,195 raised to the 0 power? 1. Nothing too crazy. Let's get wilder. Okay, we've got some roots in here, raised to x powers. We have double integrals. We have summations. We have curl, which is like Calc 3 sort of stuff. I don't care. What's the whole thing come out to? There we go. Luke's got it again. Whole thing is going to be 1. If I raise something to the 0 power, your answer is 1. Don't freak out, okay? Unless that number itself is 0. Law 7 I mentioned a little bit earlier. Okay, oh, we got Salma, we got Kayla. All right, so the live stream sort of thing seems to be working. That was my goal. Tried explaining this to some other people, that how I wanted to run the sort of online portion in classes, and it wasn't really making sense. Okay, Kayla, 1 and 1. You got it, girl. Oh, we got Liv. Okay, all right, this is working okay. Oh, and Avery. Okay, so I don't know the time delay. Maybe I have to start counting something that and do a little bit of testing with this. But well, good morning, everybody. Thank you all for tuning in. We're almost done here. Clean up a little bit of Law 7 and let you guys kind of get on with the rest of your day. I assume you probably have not 0 classes to work through. If you haven't read any of the stuff on the Google Classroom, please. We spent a lot of time drafting up that plan. Get on there, work your way through that, read through it all. I'm happy to elaborate or clarify any other questions you may have, but you have to have read that stuff first, okay? All right, Law 7. This is basically saying that negative exponents become positive exponents, but in reciprocal form. What I'm going to talk about with this moves to the other side of the fraction bar bit is it doesn't really matter where they're located. I can have a negative, in this case, basically in the numerator, and you'll see that this guy moves down. Base is the same. Exponent is the same, except it changes from negative to positive. The same will be true. Okay, Obi, you're very tough. I know. He's growling. I don't know if you see him right here. What are you growling at, bud? Come here. Oh, shut up. You're fine. Okay. That's my my live classroom in person. Again, with everybody here in chat as well. Okay, let's actually use it. Spacing on here is a little weird. Let me try making this a little cleaner. If I've got 2 squared, we're going to basically take the same idea that we had for the previous law and just expand it further. Each time I decrease an exponent from 2 to 1, 1 to 0, 0 to negative 1, I'm decreasing by 1 on those exponents. What's happening to the value on the other side? It's being divided by 2. 4 divided by 2 gives me 2. 2 divided by 2 gives me 1. 1 divided by 2 is going to give me a 1/2. A lot of people think this is going to be a negative. A negative exponent is not going to make a negative number. It's not going to happen. So don't freak out or see this stuff, and then you've got to train your brain to break that one real quickly. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is now a half. 2 to the negative first is 1/2, which is the same as if we use that law property that we had. I'm going to write 1 over. I'm going to copy the base. The exponent is a -1. I'm now just going to make it positive. What's 2 to the first simplify to? 2. That's where your half comes from. 2 to the -2. If we use the property, would look like this. I'm going to write 1 over. Copy the base, which is a 2. Copy the exponent, which is a 2, but leave it positive. What's 2 squared going to be? 4. 2 to the -2 is 1/4, because it's the same as 1 over 2 squared. We repeated that same process. I think I can put this here. 2 to the -3. That's going to give me 1 over 2 cubed. Oh, look at this handwriting. This is better than normal. That 2 cubed is going to be 2 times 2 times 2, which is 8, which also matches the pattern. If I divide right here, 1/4 divided by 2 is going to give me 1/8. We're not just making these rules up. They do exist based off of other established math laws, which is why they're all going to work in concert with each other. How do we do it now? And we got some variables in here. Put a fraction. I'm going to put a 1 up top, and the reason is there's a coefficient that's a 1 right here. I didn't really explain that before. If we do other things where there's different pieces that are multiplied, those might still remain in the numerator. The -3 only goes to this a. The a is the one that's going to move down, and the exponent's going to become positive now. We'll get to some stuff with this. There's some, I'd say, trickier ones that are going to force some issues with that on the practice sheet that's attached to the assignment on Google Classroom. It also works in the denominator. Effectively, what you can do is basically move this guy from the denominator with a negative up to the numerator. You can write this as if p to the 4th, what's in the denominator now is a 1, which is just p to the 4th. If you really want to convince yourself, and I realize I'm getting a little long here, so we're going to try and cut this, you could write this guy as 1 over p to the 4th, deal with the fraction division, flip it up by multiplying by the reciprocal, you're still going to get p to the 4th. At this point, I notice none of these guys have the same base. All right, I've got a bunch of different bases, so I can't do any of those earlier laws 1, 2, or 3. I don't have any exponents outside. I only have some negatives right here. W cubed is going to stay right where it is. It's a positive exponent. We generally want positive exponents. M to the 9th is positive. We're going to leave it right down there. There's nothing to do with those. This x squared, though, or sorry, x to the -2, that's got a negative exponent. We're going to want you to write your answers with exclusively positive exponents. This -2 is going to move down. I copy the base, change the exponent from positive to negative. If I repeat the same process with a p to the -4th, that guy's going to move up. There's now a p to the +4th. These first two didn't change because they were already positive exponents, and you can kind of see how the locations of the other two changed because they have a negative exponent. Take a quick moment to look at these. These are not the same. We see this one happen all the time. And I've kind of been hitting at this throughout sort of the year. Let me pop out and show you what I mean a little bit more. In this case, this is 3 times x squared. Only the x has that 2. The 3 does not get it. This, however, is where we're allowed to distribute this in, which will give me a 3 squared and an x squared. Clean that up. This guy's going to be a 9x squared. You should be able to hopefully ascertain the difference there. What's different about these next two? This is something that I've been hammering all year. In this first one, I'm allowed to use that law 3 property. Take this guy and distribute it in, or sorry, I guess kind of law 4 and 5. But 4 and 5 are just kind of a 3 but for more. This would give me a 3 squared and x to the 6th. It's our old friend addition or subtraction. This other one here, I'm going to change to red. People want to do this. You are not allowed to because of that addition. You would have to write that guy out and go through all sorts of nasty distributive property stuff to clean that up. Don't do it. Okay? This right one right here, absolutely not. Never one time. Stop, 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 stop. Don't do it. It doesn't work. It's not going to work. Okay? And even though the world's a little bit different now, great. Still doesn't work. Okay? Last one here is a huge issue. What's happening in this first one is this is technically the opposite of, thank you, auto rotate, opposite of 3 squared, meaning it's a -1, and then I multiply that by 3 squared. This guy right here is going to turn out to end up being a -9, because I'm taking 3 squared and afterward making that negative. The right side here, this is saying I want to take a -3 times a -3, multiply those, what are you going to get? Oh, sorry, shouldn't do that. -3 times -3 is just a +9. This gets real tricky with even powers because that's going to basically cause some flip-flopping of those values in that case. Be aware of these. We've got some stuff built in, and take advantage of those office hour times. Office hours for, I guess, me for what's a Wednesday? They're going to be from 10 to 12 every Wednesday, or they'll always, if there's a change, it'll be posted on those calendars. So you can pop into the, click that calendar event, pop into the meeting with me and ask any questions, okay? I've attached this to the assignment on the Google Classroom. Please, if you want to download it and print it, if you want to just handwrite sort of your stuff out and take a picture and send me the work, great. Please, for my own sanity, when you send me an email, put your name, the class period, and the class name all in the title, okay? We're getting a lot more emails because of some of the chaos of right now, so if you can just take that little bit and do that for all your teachers. Put your name so they can easily find it, put what class it is and what period it is, and that's going to save everybody some real headaches here, all right? Well, thank you for tuning in. That's sort of the first one. Schedule can be variable for some of this stuff. This one should cover a little bit. This assignment, this guy's not been updated here. You'll see on yours, it's being assigned currently this Wednesday. I want it by Saturday evening, okay? That's maybe a long time, but we've got a fair amount to, hey there, Irving, you have a good day too. Fair amount of time to ask questions on this. We've got at least 2 hours of office hours every day, and if there's some time where you're like, hey, this is not making sense, and I know it's not office hours, ask me if I can pop in, and if we just have a quick meeting to figure some of that stuff out, okay? Ask early, ask often. We'll get you all through this. The advantage of this is it's probably going to be an easier end to Math 4 than it would be otherwise. Thank you, Liv, for tuning in, and we'll see you all sometime in the future, okay? You guys have a good day.